Okay, gang, so like I said, for these last two pages, I'm just going to briefly go over them. So for the squeeze theorem, you first had to apply the limit to each of the three sections. I was looking for that. This squeeze theorem is based on taking limits. This is limits. You're trying to find the answer to this, having it squeezed in between two absolute values. One of the absolute values is face up, shifted A units to the right, B units up. The other absolute value is shifted A units to the right, shifted B units up, but then this absolute value is face down. So just as like a basic graph, you have something like this with a function occurring in between it, and you're squeezing it as X goes to A. So I wanted to see that you took the limits of each segment and then plug the A value in to the, so you're plugging, right, you're doing the golden rule, you're plugging into the limit, and then you can see that A minus A goes away, and you're left with that the limit of F must fall between B and B, so therefore the limit has to be B. In case I said that first part too quickly, this is an absolute value face up, this is an absolute value face down, and they happen to be right on top of each other. That's why you're able to evaluate that the limit is B. Okay, and then for the intermediate value theorem, I asked you to say that it's continuous on the segment because that was a prerequisite for being able to use the intermediate value theorem. Of course, I'm going to give you something that's continuous, otherwise we can't do the problem. So by saying I was asking you to do that, I was definitely going to give you a continuous function on the segment. The second thing I asked you to do was to plug in the initial domain and the end domain, so your x sub 1 and your x sub 2, to plug it into the function. So x sub 1 was -1, x sub 2 was output was 29. So you know that the range of the outputs go from -1 to 29. And the biggest thing I was asking you to do when you watch the video was to use the intermediate value theorem, because the intermediate value theorem is what's guaranteeing that you have all the intermediate values. So by saying this was the key piece I was looking for. I wanted you to say that the intermediate value theorem was guaranteeing that since you have all the output values between -1 and 29, that therefore you must have an 11, because the intermediate value theorem guarantees that. Just in case you can't read my handwriting, it says since f of 0 is less than 11 and f of 5 is greater than 11, the intermediate value theorem guarantees that there must be at least one value of c such that f of c equals 11. Okay, gang, that's it on the test. You can certainly email me questions. I know I went through this sort of fast, but at least you have more information on each question, and you can prod me further for whatever you need to do well on the retest. Okay, that's a wrap then here. I hope you have a lovely day. I'll catch you. Bye-bye.